This week we'll be talking about linear functions, linear equations, and their graphs. A linear equation is where the variables in our equation have no other powers or exponents other than maybe 1. So if we have something like 2x plus 1 equals 4x, even though x appears twice in this equation, this is still a linear equation because the exponent, which we usually don't write if it's just 1, is just 1. Notice, even though we can have parentheses, if we were to expand the second equation out, 2x minus 6, that's still linear on each side of the equal sign, and so this is still a linear equation. Even when we have coefficients that are decimals or fractions, as long as there's either no written exponent or the exponent is specified to be 1, then we have a linear equation. In order to solve a linear equation, we're going to pretty much do the same steps each time. First, we want to simplify both the left and right side of the equation as much as possible, getting rid of things like parentheses. Next, we want to add or subtract all the terms that have our variable to put them on one side of the equation, and all the terms that don't have a variable to put them on the other side of the equation. This is called collecting like terms or combining like terms. Effectively, we want to get all of our variables on the left, and we want all of our numbers on the right. And finally, we want to divide by whatever coefficient is in front of this variable. To get our variable by itself, we want to get x equals some number, and that will be our answer. Let's practice. Let's say we have the equation 2x plus 4 equals 3x minus 1. Just as the instructions said, we want to get all of our x's on one side. We want to move this 3x over to the left. And so we're going to subtract 3x from this equation. However, everything we do on one side of the equation, we're going to do the same thing on the other. This gives us 2x minus 3x plus 4 equals 3x minus 1. Notably, when we collect our like terms here, this simplifies to give us negative x plus 4 equals 0 minus 1. Secondly, we want to get all of our numbers on the other side. We're adding 4 on the left, so let's subtract 4 over here. We'll do the same thing on the right, and this gives us minus x equals minus 1 minus 4. That's the same thing as minus x equals minus 5. And finally, we want to get rid of this minus sign. We'll divide both sides by negative 1. And that gives us our final answer, x equals 5. If we want, we can check by plugging back x equals 5 into our original equation and making sure that both sides match up. Now usually we won't go through this in quite as much detail as I just did there, so we'll try the second one and I'll combine a couple of these steps. Step 1 for this problem here is to expand these parentheses. Instead of 4 times x minus 2, we're going to look at 4 times x and 4 times minus 2, giving us 4x minus 8 equals 6x plus 1. Once again, we want to put the 6x on one side, the minus 8 on the other. And so we're going to do this all at once now. We're going to subtract 6x from both sides, and we're going to add 8 to both sides. Doing both of this at the same time and simplifying, we get 4x minus 6x, that's minus 2x, equals 1 plus 8 is 9. Lastly, we want to divide both sides by this coefficient minus 2. These will cancel, and we'll be left with our final answer, x equals negative 9 over 2, or we could write that as a decimal, minus 4.5. Notice that even though all of our coefficients were whole numbers, we can still end up with a fraction or a decimal as our final answer. Now, sometimes our equation itself will be presented with fractions. In that case, our final answer should be given as a fraction, or sometimes it'll work out that our answer is a whole number. If we practice this one, instead of putting all of our numbers on the left, we can see it would be easier to put them all on the right. because all of our numbers that don't have a variable would be left over on the left. So let's subtract minus 1/2 x minus 1/2 x, and we're left with minus 6 equals 2/3 x minus 1/2 x. If we want to simplify this, we need to find a common denominator. For example, we could divide both of these by 6. So this becomes 4/6 x and 3/6 x, which simplifies to minus 6 equals 1/6 x. In this case, we could divide both sides by 1/6, but it's probably a little easier to think of this as just multiplying by 6. And that gives us our final answer, minus 36 equals x. So we'll notice that even though we started off with fractions, our final answer was a whole number. Sometimes we're given decimals instead of fractions. In this case, we should continue to use decimals and write our final answer as a decimal. Once again, we could subtract all the terms with an x in them to bring them on the right. In this case, we would add the terms without a variable to bring them on the left. In this case, we might subtract 0.23x, and we might add 16.3 to both sides. This would give us 6.45 plus 16.3 on the left, and 1.67x minus 0.23x on the left, or equivalently 22.75 equals 1.44x. And it's totally fine that we put our x's on the right instead of on the left, as long as we're putting all of our x's on one side and all of our numbers on the other. We could divide both sides by 1.44. And this is going to be a little messy. It turns out that this decimal is x equals 15.7986111, repeating. Depending on if this is a homework, it might specify the number of digits to put in. So we might say this is 15.8 to 1 decimal place, or 15.80 to 2 decimal places, or more if it asks for more.